I think one of the biggest hindrances of my technology here is the application of the type of water I'm using. Now, if you see previously in my videos, the water here, the tap water, is over 600 parts per million. Not 6, not 60, 600. So in this graph here, in this image here, we've got river water, which is 45. So my water is like somewhere between here and ocean water, which is on the far end of this spectrum. And you saw my previous videos here when I was using RO filtered water, somewhere between 20 to 24 to maybe 50 parts per million. That's at least in the middle of this dielectric value here. So maybe, and I've seen when I've used the RO water, I get much higher voltages at the cell, much greater performance than using the tap water, which is down here. So maybe that's part of my whole thing is I need to be using purified water and or distilled water to be operating in the parameters more of what Stanley Meyer's was, because he talks a lot about, using rainwater and how the particulates are only, 20 parts per million or so. And if I'm using 600 parts per million, then that is just absolutely out of the bounds for this technology. So I think we're just going to dump tap water altogether and just start using purified water. Because in game anyway, we can recycle the water, whatever water source we're using, we can recycle the water into the system to obtain a very pure water anyhow. So we should probably be on this end of the spectrum, not down here towards ocean water. All right, making some progress here on the gas resonant chamber. We're going to reprint that top piece right here. This bottom piece turned out pretty well. We got our positive negative there for the cell, and then on this side we're going to have the actual positive out for the electron extraction. The real question is will it be sealed? Will it seal? I've got rubber gaskets on this outside one, and those little holes right here, we're going to squeeze as much of this clear silicone as we can into these little slots to seal them up, hopefully make them airtight. I don't want to end up like Kevin West and just having to epoxy the fuck out of everything. Ha 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 ha. Something like this. You can see that top part that's separated by that little plastic piece. That'll be our electron extractor grid. And given this is the very first model I'm doing of this thing, I'm sure there's going to be many iterations and failed attempts and etc. etc.
This is Stan's Revenge.
They said you couldn't perform electrolysis or get gas from unprocessed water without an electrolyte. I did. They said you couldn't do it without heat generation. I did. They said you couldn't do it with distilled water. I did. They said you couldn't do it with voltage. I did. Everything Stan has taught me that I have been able to recreate has become true. So there's no reason for me to expect that electron extraction won't do exactly what it's said to have done. Given I am building it correctly. Obviously, my first few cells were pathetic, and I had no idea what I was doing whatsoever. Just starting out, in the HHO realm, and just was so excited just to get a few bubbles out of the cells that I had. And then I had the breakthrough with the equal opposite polarity pulses, and that being able to actually generate a healthy amount of HHO gas with no electrolyte. And then as I was able to increase the voltage even further, gas production increased even exponentially. And I believe yet again I'm on the cusp of rediscovering this segment of the technology. And even if I am consuming more energy creating the hydrogen, even though what traditional means is, once you take it to the atomic level, even if I dump in double the amount of energy to make this system work the way Stan says it does, we are receiving a magnitude of more energy output from the atomic condition of the hydrogen fracturing process. So at that point, it won't matter that I'm consuming 300 watts at my cells, plus another 300 watts, at the subsequent cells, the hydrogen, the gas processors, etc. Because for one, with the electron extraction circuit, you are literally pulling electrical energy from the atoms of the water molecule itself. And if that is the case, that's obviously a reduction in the amount of energy that's required to actually make the process work. That also introduces particle impact as I'm doing this. So as I'm destabilizing these atoms, electrons start being ejected from the atoms. The atoms absorb a positive charge through the electrical voltage zones and the laser energy, the photons that are being injected into it. So it ejects these electrons. These electrons start bouncing around, colliding with other particles, generating, quote, geometrical values of hydrogen gas production. Which brings me to, if you look at the existing stack of the water fuel cell, as Stan had it, it was a series of resonant cavities. And I believe those resonant cavities sequentially were literally just channeled into each other, but they were submerged in water. That's where you get the particle impact happening. When you have particle impact happening in the water bath, you start creating even more hydrogen gas from the water bath while destabilizing the atoms themselves. And then you have at the top the hydrogen gas gun, which is basically the gases traveling through a resonant chamber, destabilizing them to a point of thermonuclear energy release. And if that be the case, there's no need to generate volumes of HHO gas, because at that point you only need to be producing very, very little gas, perhaps even 1/3 of a liter per minute. Where I'm already at, even less maybe, because hydrogen is 2.5 times more explosive, or there's 2.5 times the energy released in hydrogen than there is gasoline. But then when you take hydrogen to the atomic condition, 1 gallon of water is equal to 2.5 million barrels of oil per Stan Myers. A tremendous leap in energy. If we can tap in just to a fraction of that calculation, there will be a tremendous amount of energy released from even the smallest amount of hydrogen gas generated.
This is Stan's Revenge.
A video for everybody that has previously claimed that I'm doing this with amperage instead of voltage. I want you to pay attention to something here. I'm going to pull the amperage on this cell up to about 1 amp. See, it starts bugging out, so that's about 1.2, if that be true. 600, 800, somewhere around there. That's that waveform I'm getting. But we got 67 volts at the cell, and you can see here we have next to no production on the cell. It's just, some, but not much. But what I want to point out here, let's see, we're still hopping around 6. We're going to kick it up a little bit further. Even getting the cell up to 70 some volts. Let's say 75 volts. Let's go even higher. And we are tuning up 9 amps in this configuration, input-wise, but just really no production to speak of at this amperage level of a 1 amp or so. Reversing my primary, getting me back to a configuration previously, we can kick this thing up to 140, 50 volts or more, and we still only have 700 milliamps at the cell. But brother, we got way more production than previously at that same amperage level. So with the higher voltage, allowing voltage to do the work, we're keeping amps squelched here in this configuration. There's my equal opposite polarity pulses, keeping a voltage potential across those cells practically at all times. But we're still at 1 amp here, and we're getting production because we have the voltage to do the work. We can have the same amount of amperage at the cell, but if we don't have the voltage, it ain't going to produce, because it is a voltage process, a strictly physical process of utilizing voltage zones to break apart the water molecule, as opposed to actual amp consumptions, amps moving through, electrons being exchanged, etc., etc. In this case, the amperage consumption is basically just what's consumed in the circuit, and what is used to keep those plates charged. Back to my 3 cells there, we're still managing about an amp. We're getting 142 volts span across all those cells. Well, we do get much greater gas production.
This is Stan's Revenge.